Hey guys, just making a short video here to talk about end behavior of polynomials. Let's say you have a polynomial like this. X squared minus 50x plus 100. So in this example, let's see how it behaves when x is 0. When x is 0, if I get this 0 and I plug it into my equation in those spots, then my equation becomes 0 squared minus 50 times 0 plus 100. Well, this term disappears completely, this term disappears, and the only term that survives is the last one. Last one is 100. So here the last term is pulling all the weight. Okay, what if I have the x value as 10? If the x value is 10, then that becomes 10 squared minus 50 times 10 plus 100. Well, in this case, I got 100 minus 500 plus 100. This term is really dragging the whole thing down, making it super negative. So when x is 10, that whole thing is going to be negative 300. This one is doing most of the work. But now what if x is a really big number? Let's just pick something like 1,000. If x is 1,000, this is 1,000 squared minus 50 times 1,000 plus 100. Well, in that context, 1,000 squared is 1, 2, 3, 4, 5, 6 zeros. That's going to be 1,000,000. This is going to be 1, 2, 3, 4. That's going to be 50,000 and 100. Now, $1 million is a lot. Subtracting 50,000, these guys basically don't really matter that much anymore. So when x is big, when x is 1,000, the one that we care about is this term, and the other terms don't matter. Now, that's even more the case when you approach infinity. As you get closer and closer to infinity, you're allowed to disregard the other terms. And in fact, I'm just going to write here shorthand infinity. So if I plug in infinity squared, and again, I don't have to plug it into the other terms because they're not going to matter that much. I have to consider how what's going to happen. So infinity squared is just infinity times infinity. These are both positive. It's infinity. What if I do something like a really big negative number, like negative infinity? If it's negative, if I do negative infinity squared, again, a negative times a negative is a positive. So negative infinity squared is going to be positive infinity. So if I graph this, if I do a really rough graph of this shape, here's my x-axis. This side is infinity, this side is negative infinity. And as let's say I start here, as I move to the right, as I approach infinity, then my y value has to go up. And here as I approach negative infinity, as I go to the left, my y values also go up. And this means that quadratics behave like you already know how they behave. Quadratics are smiley faces. If it's y equals x squared, it's a smiley face. If it's y equals x squared minus 50x, eventually that thing will act like a smiley face. So quadratics are smiley faces unless we make them unhappy by putting a negative sign in front of them. Negative x squared is sad. Negative 5x squared gets sadder even faster. Okay, so that's kind of the theory behind it. Now let's just summarize what we can say about end behavior. Let's make a little table here. Let's say we have x to the 4th, x to the 6th, x to the 10, ... x to the even, some even power. Well, all of these things with an even power, including x squared, they're always going to behave the same basic way. They go up on that side, they go up on that side, and in between you might have some wiggles and some highs and some lows, but generally that's their end behavior. The terms in the middle, the x to the 9th, the x to the 7th, these might make the wiggles, but ultimately the ones that always win, the ones that call the shots, are the leading term, the degree. The degree is the biggest exponent. Okay, so even degrees. Even degrees behave like this. They're either smiley faces or frowny faces. This is if the coefficient's positive. This is if the coefficient's negative. So if I have something like x to the 6th minus 3x squared plus 5, then it's going to be a smiley face overall. And if I have something that's negative 3x to the fourth plus a bunch of stuff, then overall it's going to be a sad face. Okay, let's talk now about odd degrees. Let's start with something like y equals x cubed. Now, if I make my table of values, x and y, let's choose some positives first. Let's say we do 3. If x is 3 and we plug it in here, y is equal to 3 cubed, which is 27. Okay, let's say I do something, go down and do 2, then 2 squared is 8. I do 1, 1 squared is 1, and 0, 0. What happens if I go negative? If I plug a negative 1 in, if I plug this in, then y equals negative 1 cubed, which is negative 1 times negative 1 times negative 1. A negative times a negative times a negative becomes a negative. Same thing for negative 2. And same thing for negative 3. So when I graph a cubic function is going to look like this. And the same thing for a 5th degree function. It's going to look like this. Or a 7th degree function. Now it might have some wiggles in it, and those wiggles could be caused by something like negative 100x squared. That could cause a big wiggle, but overall, this is the term that'll be calling the shots. So what happens if you have a negative coefficient? A negative coefficient is like negative 3x to the 5th. Then that negative is going to change the direction. It's going to go, as you go left, it'll go up. As you go right, it'll go down. So the way to describe this is if it is a smiley face like this, we say that as you approach, this is negative infinity. So as you go left, you go up. Now the way you describe as you go left, you go up is you write down as x approaches negative infinity. This is negative infinity over here. As you get towards the left, your y value goes up. And on the right-hand side, as you approach infinity, your y value also goes up. Okay, so this is how you describe a smiley face. Now to describe a sad face. To describe a sad face, you say overall, as you go to the left, as your x value goes to the left, as you approach negative infinity, your y value goes down. It goes down towards negative infinity. And as your x value goes to the right, your y value also droops down to negative infinity. So frowny face, we describe its end behavior like that. And now with a 3rd degree or 5th degree thing with a positive coefficient, we're going to say as you move here to the left, as you go to the left, your y values go down. Okay, so if you have a negative number like negative 100 and you cube it, you have negative infinity, and you cube it, negative infinity. And as you move to the right, then your y values go up. And if we throw a negative in front of it, like y equals negative x to the 7th, then you'll have something like this, which means as you go left, then you go up. And as you go to the right, you go down. Okay, that's end behavior.